Okay guys, here's the last video for today. This is going to cover pages 9, 10, 11, and 12. Alright, so a common question with this stuff is not to solve the whole triangle out, but to figure out how many solutions do the following triangles have. And what this really means is solutions is how many possible triangles. So are there one, are there two, are there none? In order to figure that out, let's just draw, to start, a general triangle. Okay, I'm going to label it ABC angle-wise. So that means this is side A, this is side B, and this is side C. Okay, so basically there's two ways that we can have one triangle. Okay, the first is if side A here, right? If side A here actually drops straight down, right? So it's not drawn like that. It drops straight down and it forms a 90-degree angle. Okay? Right there. All right. That's only going to happen if A is equal to the perpendicular height. Okay? So I'm going to write that as our first case, is if A is equal to H, we have one triangle. And I'll just put in there that that means that we have a 90-degree angle. Okay? We'll get to like how to look at that in a couple minutes. But second case, well, now let's assume that A is a little bit longer than H, right? And maybe it's hard to see. I'll try and draw another color, but if that's the case, whoops. Sorry, let's go back. Let's set a different color. So if that's the case, maybe A could go this way, or it could go this way. So it's actually going to form two different triangles, right? So I'm going to say if A is bigger than H, but here's the thing, it has to be smaller than B, okay? It can't be bigger than that side. But if this happens, then we have two triangles. And I should say then we'll have one acute angle and one obtuse for, I guess that would be for angle B. Yeah, and mine as well. Just put that in for this too. That's angle B. Yeah, remember, so this is angle A, this is angle B, angle C is up here. So the 90-degree angle right here, that would be B, dropping over like that. Remember, side AB, side C is free to be whatever we want. So it could be this, it could be this, it could be this, it could be this. Case 3, just a couple more, guys, okay? Case 3, well now, suppose that A is still bigger than H, but it's actually also bigger than B. Well, if that happens, right, that means it's, I'm going to draw it pretty extremely, like it's not a good, it's going through the A. Let's try that again. Let's do green. So that means like maybe it, extends way over there. Okay? Well, if we try and swing it, we try and say, oh, let's move it over there. Well, the problem is, then this angle's gone, right? So, there's only one way that can happen, right? If if A is out over here, okay? So if A is larger than B, we have one triangle, and that means that angle B is acute. And then maybe the last one that we're not kind of thinking about is, well, it's possible, right? It's possible that side A is shorter than the perpendicular height, right? It's possible that that's the h. Well, they could give us an a value that's like half of that. All right, so boy, I'm really going to town with these colors, but if a is less than h, then we have 0 triangles. Okay? So that is case 4. So the question is, how to figure this out, right? How do we figure out the relationship between A and B? Well, if we look, do we have any where A is bigger than B? Yes. Right here. Right? A is bigger than B here, right? That side is bigger than that, so this is only one possible triangle. Okay, so this is one triangle. Here's one that's pretty suspicious because A is 2 and B is 10, right? So it's that. And we also have this angle. So we could compute, right? We compute this perpendicular height if we have B and we have the angle, right? So we can say, let me start with that here. So we can say that in this case, the sine of 50, if we have a 90-degree angle, should be h over b, which is 10. So h has to be 10 sine 50. And that number, let me get my calculator here. You guys can probably do it faster than me. That's going to be 10 sine 50. 10 sine 50 is 7.66. 7.66. Well, that side A is way smaller than that, right? So this side opposite angle A isn't even long enough to touch down at a perpendicular angle. So this is not possible. Let's do a different color because I'm getting kind of crazy with colors here. This one, so I'm going to say A is less than 7.66, which is equal to H. No triangle. Okay? That's no triangle. This is one triangle. Last case, A is 7 and B is 11. Well, now we can use this same ratio and see what happens, right? So let's write for here, and I'm sorry, it's kind of messy here, that the sine of 32 degrees is equal to h over 11. So h is 11 sine 32 degrees, which is 11 times sine, not psi, sine 32. That's 5.83. 5.83. A is bigger than that. 7 is bigger than 5.83. It's less than 11, so it's this case here. Okay. So 7 is bigger than 5.83, but less than 11. So 2 triangles. Wow. All right. Maybe I should highlight those just so it's a little bit more clear. So for number 1, we've got no triangle. For, let's do number 2, we've got 1 triangle. And for, let's try this color. 3, no, I don't like that. I don't like that color. Let's do a nice turquoise or whatever. No, it's a light blue. For 3, we've got 2 triangles. All right, hope that made sense. This is a little bit, this will be a faster slide. when to use which formula. So back to basics. If we have a right triangle, right? The whole reason we're learning this stuff is because if we don't have right triangles. But if we have a right triangle, keep it simple. Use your SOHCAHTOA. Use your Pythagorean theorem. Okay? If you don't have a right triangle, cosine rule, if you have three sides, right? So you don't have an angle, you can't match up a pair. And if you have two sides and an included angle, again, in either of these cases, we don't have a corresponding side and angle. Sine rule, if we have one side and two angles, because remember, if we have two angles, really we have a third, so we have one side and its corresponding angle. And then this says two sides and a non-included angle, but be aware of ambiguous case. Okay, so really, to make this a little bit simpler, the way I like to remember it is sine rule. You use if, have, wow, let's write that correctly. If have a side corresponding angle and anything else. So it could be a side or an angle. Okay? Anything else, go to cosine rule. All right. Got two examples here. I'm actually going to stop the video, but I will write out solutions. So, yeah, this one's asking for finding the area of the property. Okay, and we have two different units to use. And it looks like, we have two triangles here. We want to find the total area. And then this one's giving us a polygon, and they want lengths for x and y, or I should circle the correct thing, x and y and x in meters. All right? And just a reminder, you got some homework. It's all out of the textbook. Okay, so you got the Hayes book for a couple questions, and then you got the Forrester, the old school book for a couple more. All right, guys, hope that was helpful. Contact your teacher if you have questions, and good luck with the start of this